Welcome to the League of Biblical Mathematics. Yes, ladies and gentlemen, we have changed the name from the People's Debate League to the League of Biblical Mathematics. Why did we make this change? Well, we wanted something that spoke directly to what we were doing. We are searching the Bible for hidden secrets of math and finding ways that we can use them and apply them in today's society. We are using the Bible to search for math, to find ways that we can use them into today's society. Because we believe that math is the only way to enlighten and to uplift our people and all people. So today I'll be giving you the third edition. And this here is a pretty long read. So I want to embrace you for this. But this here is very important. These people, this period in time, is very significant to math. And this may have been an influence on Kemet, as we know it. The ancient Babylonians, ladies and gentlemen, the ancient Babylonians. They have very extensive math history that we must explore. So with that being said, and no further ado, I would like to share my screen. There we go. Share my screen. I try to find very credible sources to write these or to give you this information from. This one here, as you can see, is CDLI Wiki, Library Knowledge of Cuneiform Digital Library Initiative. Oxford, University of Oxford. Babylonian mathematics. Trying to see who wrote this particular article. Okay. Can't see who wrote the particular article, but we do know that it's from the Oxford University. and the Cuneiform Digital Library Initiative. So let's dive into this. Babylonian mathematics. Introduction to Babylonian mathematics. Mathematics was an active discipline in Mesopotamia since the earliest periods of writings in the mid 4th millennium BC. However, if we are to judge by the number and age of the cuneiform mathematical texts we possess, it appears that mathematics reached the apex during the Old Babylon period. At the outset, it should be mentioned that Babylonian mathematics was largely an applied science. Unlike classical Greek mathematics, Babylonian mathematics was not centered around geometric figures or abstract periods of mathematical theorems. Instead, it formed on instead it focused on practical problems that could be solved algorithmically. Many texts from that era are simply multiplication tables at various size designed to aid scribes in performing complicated arithmetic. Other text describes fairly realistic situations that might arise in economic exchange or engineering endeavors, such as constructing dams, excuse me, and realistic situations that might arise in economic exchange engineers endeavors, such as construction dams, canals, and brick walls. Sorry, I read that twice. Brick walls. There are many examples of text dealing with more general geometric or algebraic problems, but these are visual stated in terms of concrete situations, such as the division of a field or this distribution of rations and area always discuss uses specific value. Thus, there are very few instances of Babylonian proofs or even instruction tablets that outline a general method of solving a class of problems. This is not to say that Babylonian mathematics did not understand the abstract principles behind their solutions. That simple the thought of them in the context of concrete examples, simple to the way a mechanic might think of physics principles in terms of an automobile. An example of such concrete mathematical text comes from YBC 4669, which states 2/3 of 1/3 made my ration I have eaten, 7 remains, which was a little ration. Sorry, which was the initial ration. In modern rations, the problem asks to solve for S is the equation 1, 2 dash 9 S equals 7. Contrary to the preceding example, Babylon math problems can be quite complicated, involving large numbers and multiple unknowns, sometimes as many as 15. See Pittsburgh, PG, page 559. Though the problems are physiological in construction, and so input values are skillfully chosen to provide a clear answer. The Babylonian number system, perhaps the most widely known fact about Babylonian mathematics, is that it used an artificial sexagesimal number system. That is, the place value corresponded to the positive negative powers of 60. For example, the number 4,000 would be expressed as 1,640 equals 6 times 6 equals equals 1 times 6 over 2 plus 6 times 60 plus 40 times 1 is the Gizmo notations. I might mess that up, so please forgive me. This Babylonians had cuneiform symbols for 1 and 10, which they combined like tally marks to express numbers between 1 and 59. They use place value notations for large numbers and fractional numbers just as we do now, except they did not have a symbol for 0 to indicate into place values. The Babylonians also understood the concept of fractions or ratios or ratios. They did not have a special symbol corresponding to the decimal point, nor did they have anything like our modern fraction notation. Instead, they based their computations on the concept of reciprocal numbers. The reciprocals of the number is just n equals 1 over n, 1 dash n. If n has a finite sexagesimal expression, then we say that n is regular. Otherwise, we can call n irregular. Likewise, an irregular fraction is a fractional number which non-terminating of these numbers and their reciprocals. Such tables would often consist of pairs of columns of numbers of the form Iggy and Gal, Pi ancient on Gal. I'm not sure what that was all that means. Or just in, where is the reciprocals of n? For instance, 230 would mean that 30 times 60 over 1 equals 5. 5 equals 5 is the reciprocal of 2. The Babylonians avoided working with irregular numbers and irregular fractions when possible, which sometimes meant rounding or figuring out ways to express irregular fractions in terms of sum and products of irregular fractions. The Babylonians did not, as a rule, write mathematical equations as precisely as we do. Until late old Babylonian times, they did not have symbols for plus and equal, and they did not use symbols to stand for variables. Still, they understood algebra well enough to perform most of the manipulations we do today, such as fractions, such as factorizing expressions, adding, subtracting, multiplying, or dividing both sides of an equation by the same quantity and taking roots. They demonstrate remarkable ingenuity in solving equations, even their lack of suggestive notations. Okay, I'm going to repeat this out. This is very long, and not really the one I'm boring about it. For instance, the Babylonians might consider the problem, given instance a rectangle whose areas is the sum of the length and the width are known, determine the length and the width. Suppose the length plus the width is 1 plus W equals 50, and the area is W, and the width equals 600. Moreover, suppose the length is greater than the width, then working only with the specific numbers given in the problem, the Babylonians would first compute half the sum of the length and the width, i.e. H equals HW, 2 equals 25. Then they would compute H over 2 equals 625 and subtract the area from this, getting 625 minus 60 minus 100 equals 25. Finally, they would take a square root of the resulting add this to the half sum to get I equals 30 and subtract it from the half sum to get W equals 20. When the above proceedings is worked out using the variables I and W, the solution method becomes clear. The Babylonians had mathematical the Babylonians had a method of solving many types of problems and solving conjugate quotations, sometimes based on reciting to the problems like the ones above. There are even instances of solutions of cubic quotations, yet while the Babylonians were, were aware of instances where the existence of irrational numbers like square root 2, I guess that's what that means. They did not formalize the concept to the extent the Greeks did, where where the concept to the compute rational approximately similarly their estimated of the pi usually ended um, being simply 3. I'm not finished reading, I'm sorry. The league, the legacy of Babylonian mathematics. Because of the great antiquity of Babylonian mathematics, scholars have often conjectured about its influence on development of mathematics in the ancient cultures, although the parts of the cuneiform text from the third millennium makes conclusions about Mesopotamia's mathematical influence highly speculative. And in the second and first millennium, there is strong evidence for cross-cultural mathematical exchange during the Old Babylonian period. It is evident that Babylonians' mathematical techniques were known as Susa, Maria, in Egypt. Later, in the great cultural movements of the first millennium, the influence of Babylonian mathematics can be seen in numerous mathematical texts and numerical tables from Irsa, Assyria, Ugat. Sorry, you can start over. Please forgive me. Uh, okay. I'll stop from here. The influence of Babylonian mathematics can be seen in numerous mathematical texts and numerical tables from Assyria, Ugat, and Palestine. Babylonian mathematics influence beyond the ancient Near East is harder to identify, although conjectures have been made about the relative relations to Greek, Indian, and Chinese mathematics. In the case of the Greek, arguments for relationships are slightly more cogent, as ancient Greek communicators unanimously claimed that their geometric and astronomical science came from Egypt. And Babylonians indeed, famous Pythagorean theorem was known in Babylonia, well over 1,000 years before Pythagoras. Thus, while the Greek radical formulated mathematics along the lines of abstract geometry, many of the concepts and theorems they used certainly were known as Babylonians long before. Look at references, websites. Black Jeremy, A. Graham, G. Cuneiform, Esther, Look There, Eden, Esther, Esther Flicker Hawk, Eleanor Robinson, Gaber Zoyamoy, 1981, The Electronic Text Corpus of Sumerian Literature, um, Broken Melvin site, Museum of Mathematics, books and articles. Okay, let's read all that. So you check the article out. These are the web. You read this if you want to. This is the information that they guys gathered together that you can check out. I'm not gonna read any more of this. But, but if you notice all that I read, I think the one thing that I got out of it was the 60 decimal systems, right? And the 60 decimal systems, right, help create, or that's how many believe that the 360 number breaks down from the 60 decimal systems, right? And there are so many numbers that go into that 360 decimal system that I'll try to do my best to show later. I don't know how great I'll be able to explain it, but I will show it to you guys later. I want you guys to see this. I want you guys to see this information of Babylon and what they did. Um, Again, I appreciate you guys and your time being here. I know this information seems overwhelming at times, but I think it's important to share this information because we have to get rid of this spooky dookie. That's all it is, just trash. And use the Bible what it was originally used for. It's a tool. Not to be worshipped. People are worshiping the book. If you believe in God, you worship God to use the book for what it's used for. And it has many different uses that we can possibly use it for. So that's my time. Thank you guys. Please like, share, subscribe to the video. And leave a comment in the comment section. And if any of you guys, want to join me and come on and dialogue with me, I would definitely love to hear from you. So that being said, that's my time. You guys have a great day. Peace and love.